Hi guys, today's lesson is 3.9 on analyzing rational functions. So we're going to start off with a definition of something called the point of discontinuity. So what this is it's essentially a hole in the graph. It's a point that's not continuous. So that occurs when simplifying a rational expression, you end up canceling terms out. So we'll see a bunch of examples of that happening in this lesson. But essentially, it's going to look exactly as it would on your calculator screen as any other rational would. But if you go to find the x value, that's a point of discontinuity, you won't be able to find it. Your calculator will give you an error. So here's the first example, y equals x squared minus x minus 2 over x minus 2. So the first thing I'd like you to do is just simplify this rational. The top is factorable. What multiplies to -2 and adds to -1? That would be x minus 2 and x plus 1. The bottom, I'm going to put in brackets so I can see what I can cancel easily. And I can see that I've got the same bracket on top and bottom. So this x minus 2 is able to cancel. In the last lesson, we never saw this happening. This is something that produces this point of discontinuity that we're talking about. So this is going to simplify to x plus 1. So if I were to draw y equals x plus 1, that's just a basic straight line on a Cartesian plane. It's going to have a y-intercept of 1 and a slope of 1, something like this. And that's exactly what your calculator is going to show you. But that's not actually the entire story here. When we end up canceling this x minus 2 bracket, this means that you get a point of discontinuity at x equals 2. Remember, just switch the sign. So if there's a point of discontinuity at x equals 2, we can find, using this simplified equation, the y value. The y value is going to be x plus 1, and the x we're using is the number 2. So the y value is going to be 3. This corresponds to the point 2, 3, and at 2, 3, there's actually a hole in the graph. So I'm going to go in there and I'm going to erase a little bit of the blue graph, and I'm going to draw a very obvious hole. That's what a point of discontinuity is. Your calculators, however, will not show that. They just show a continuous line, and you have to know that if you look for the x value, if you try and find 2, 3 on your calculator, it will give you an error. It will tell you that that isn't a point on the line. So what will we say then for domain and range? See if you can pause the video and figure those out. Domain and range for straight lines is just XER and YER, but we have a hole in this line at 2, 3. So that means that X is every number except for 2, and Y is every number except for 3. Let's try another example. So we're going to determine if these rational equations have asymptotes, xy intercepts, and points of discontinuity. The first step is always to factor. So this top trinomial, we need to find something that multiplies to 6 and adds to -5. Those two numbers are going to be -3 and -2. I always make sure I put the bottom binomial in brackets just so I know how to cancel these. We cancel brackets with brackets. We don't cancel parts of the bracket, so we can't just go ahead. Lots of students like to right off the bat cancel an x with an x. That is not allowed. That is happy canceling. If you've been in my classes before, we talk about that. You have to cancel the entire bracket with an identical bracket. So speaking of canceling, here's the cancellation that happens, x minus 3. As soon as you cancel something, you've immediately discovered where your point of discontinuity is. It's at an x value of positive 3. Switch the sign. Now, this simplified version of the equation is now x minus 2, quite simple. I'm going to put my x value of 3 into that equation and get a corresponding y value of 1. So my point of discontinuity, or the hole in the graph, is at the point 3, 1. Now, what are we going to use to find xy intercepts? Are we going to use the more complicated equation that we started with, or the simplified one after we factored and canceled? The good news here is that we use the simplified one. So finding the x-intercept ends up being quite a simple task. Make your y value 0, do algebra, and you're going to get 2 equal to x. The x-intercept, remember the y value is 0, is 2, 0. The y-intercept we find using the same method. Make the x 0, and you get a y-intercept of negative 2. You may have known the y-intercept just by looking at the equation because it is in slope y-intercept form. So if you did, there would be literally no algebra to show there. All right, this one, if we think about vertical asymptotes and horizontal asymptotes, we find them from the simplified version. So in order for there to be asymptotes in the simplified version, there has to be a denominator. There has to be x's in the denominator. Since we don't have x's in the denominator, that means that there are no vertical asymptotes or horizontal asymptotes. We will see an example later on where there are. I'll show you the difference between finding a point of discontinuity, which we had canceling here, and an asymptote, which would be something left in the bottom that doesn't cancel. Try pausing the video and fully factoring part B here. To factor this one, you're going to take a GCF out of the top. X squared and negative 2x can both divide by x, and when you take an x out, you're left with x minus 2. The bottom is backwards of what we usually like to see. We usually like to see the x first and positive. So the trick with the bottom is I'm going to factor out a negative 2, and then I get negative 2 plus x. The reason why I did that is because I knew if I factored a negative out, these two brackets would actually be exactly the same. X minus 2 and negative 2 plus x are the same thing. Okay, so once I factor that out, I realize that my point of discontinuity is at x equals positive 2. Switch the sign. Now my simplified equation here is x over negative 2. You can put the negative wherever you want. I'll just leave it like that. Now in this one we do have a denominator, but I told you that asymptotes are going to come from x's in the denominator. So for this one we have no vertical asymptotes and no horizontal asymptotes because x is not in the denominator. That's what you're looking for. All right, let's finish off the point of discontinuity now. I know the x, so subbing into the simplified equation, I'm going to find my y value. 2 over negative 2 is negative 1. The x and y values correspond to the ordered pair, 2, negative 1. That creates a hole in the graph. X-intercept is where y is 0. Perform algebra to get x by itself. X is divided by -2. The opposite of that is multiply. What you do to one side, you do to the other. You end up with 0. Any point that's 0, 0, the origin is going to be an x-intercept and a y-intercept. You can find that algebraically by subbing a 0 in for x. Remember, 0 on the top is not a problem. Put it in your calculator and it will tell you 0. 0 on the bottom is the thing that's a problem. All right, let's make a little note in our notes because we've talked about NPVs in the past. So I just want to be really clear that denominator NPVs they're going to result in either a vertical asymptote or a point of discontinuity, not both. So after the last lesson, you might be in the habit of looking at the denominator first to state your vertical asymptote from your NPVs. That's not true if it creates a point of discontinuity. So you have to go back to the numerator and see if that bracket can cancel first. If it cancels, it's a point of discontinuity. If it doesn't cancel, then it's a vertical asymptote. Pause the video and try factoring both the numerator and denominator for this question. All right, factored form of the numerator. What multiplies to 6 and adds to 7? That would be 6 and 1. On the bottom, what multiplies to 12 and adds to 8? That would be 2 and 6. Now, we've got a lot going on here. We're going to have a point of discontinuity and a vertical asymptote, and we need to be able to tell the difference between them. Doing this in a different color might help. As soon as you cancel a bracket that's identical on top and bottom, it becomes your point of discontinuity by switching the sign. Now, there is a bracket with x left in the bottom. That is always going to give you a vertical asymptote because the x plus 2 can't cancel with anything. So that means your vertical asymptote is x equals -2. Switch the sign. Now I'm going to write the simplified version of this. We've got x plus 1 on top and x plus 2 on the bottom. Remember that your horizontal asymptotes come from dividing the coefficients of the biggest degree of x. So the biggest x we have is x to the power of 1. There's 1's in front. If I divide those, I get a horizontal asymptote of 1. Now let's go ahead and let's finish off the point of discontinuity. We have half of the story right now. We have the x value, but it's a point of discontinuity. It has to have the corresponding y value. So into the simplified version, I'm going to put my -6 for my x value, just like that. You can put this in your calculator if you want, or you can think through it. The top is going to be -5. The bottom is going to be -4. 2 negatives make a positive. So we've got a point of discontinuity at -6 and 5/4. Don't be afraid to write fractions. We don't like decimals, we like fractions. In the Harry Potter books, it wasn't platform 9.75, it was platform 9 3/4. So write your fractions. Now, x-intercept, y-intercept, remember you're always working with the simplified version. If you ever run into some mathematical lies, chances are you're working with the original function. Okay, if you put this x equals -6 point of discontinuity back into the original, you're going to run into problems. You won't be able to find it. So you have to put it into the simplified version. Same thing for the x-intercept. I'm going to make y 0. My algebraic steps are going to be multiply the bottom up, which just gives you 0, and then -1 to move it over. So my x-intercept here is at -1, 0. And my y-intercept is at 1/2. Remember, you can always pause the video and slow that down, watch it a couple times to make sure you know why I'm putting zeros where I am and how I'm simplifying these numbers. Next question. This is the first one that is not a simple trinomial factor. These ones had x squareds. That means you can simply find the magic numbers and put them in brackets. This question has a 2x squared. As soon as there's a coefficient, you have to do factoring by decomposition. So I want you to find two numbers that multiply to 14, add to -15. Pause the video if you need to. Those two numbers are going to be -1 and -14. I'm going to write the first term and the last term, and in the middle, I'm going to write my magic numbers with x. I'm going to cut it in half, and I'm going to GCF either side. Since my first term here is negative, I'm going to take out a -7. I know that I'm factoring correctly because these two brackets match. That's going to be one part of my answer, and the GCFs that I took out are the other bracket. So all of that work was done just to simplify the top to be in factored form. The bottom has an x -7. Those end up canceling, which immediately tells you your point of discontinuity has an x value of +7. Here's the simplified version of the equation. It no longer has an x in the denominator. So that means for us that we don't have a vertical asymptote or a horizontal asymptote. Let's finish finding the y value here. 2 times x minus 1 is my equation down here. So the y value will be 14 minus 1. So if I try and find the 0.7, 13 on my calculator, it's going to not exist. It's a hole in the graph called a point of discontinuity. Now, into the equation I've circled, I'm going to make y 0 and do algebra to find x. First step, add 1 to both sides. Second step, divide by 2. My x-intercept is 1/2. X-intercepts have a y value of 0. My y-intercept I can actually see from slope y-intercept form right away if I remember Math 10C. If I don't, I make x 0 and I evaluate and I get a y value of -1. So all of these details that we're figuring out basically help us to draw the picture. I know that my y-intercept is at -1. My x-intercept is at 1/2. My hole in the graph is at 7, 13. And this is slope y-intercept form. So this gives me a linear graph with a hole in it. That would help me to say the domain is x cannot equal 7 XER, y cannot equal 13 YER for the range, and we could do a lot of work with this graph. One more example here, a little backwards thinking. We want to determine the equation if we have the details now. This is exactly the opposite of what we've just done. So we know that there's a horizontal asymptote at y equals 2, a vertical asymptote at x equals 0, and a point of discontinuity at 1, 5. So here's the information. Horizontal, vertical asymptotes, and point of discontinuity. We're trying to fill in the equation that satisfies these characteristics. The first thing I'd like to do is pull out of the point of discontinuity the bracket that cancels on top and bottom. So that always, if you look back in your notes, came from an x value. So something on top and bottom with an x canceled. Which number in this point, 1, 5, is the x value? The 1. How do we get the x value out of the brackets? We switch the sign. So what must be in these brackets with x is a -1. We've got the first part of our equation. There must be an x minus 1 on top and bottom that cancel, that give us a point of discontinuity at y equals at 1, 5, pardon me. Let's go with the vertical asymptote next. The vertical asymptote is an x left in the bottom that doesn't cancel, that gives us an NPV. This one students forget about. If it's 0, it's not a bracket that's x plus 0. It's just a plain old x, like that. That x is not going to cancel with whatever's left on top. Now, we know that there's something else on top that's going to give us a horizontal asymptote at y equals 2. So remember that this is going to be the coefficients in front of what's left. So we're going to have an x left in the bottom. What number must be in front of this x so that you divide it by 1 and you get 2? 2. 2 divided by 1 would give you a horizontal asymptote of 2. Now, we don't have any other information that helps us figure out what's in brackets here with 2x. I'm going to call it b, just some kind of variable. But we do have one other number that we haven't worked with yet that will help us figure out b. That number is this 5. We know that if we cancel our point of discontinuity, we make all of our x values 1, we will get a y value of 5. So I'm going to make y 5. I'm going to make x 1. In the bottom here, I have 1x left. And I'm going to solve for b. Really, I don't need to write division by 1. I can just pretend like that's not there. Or I can think of this as 1 times 5. 2 times 1 plus b. Do a little algebra. And b is equal to 3. So we can finally go ahead and write the entire equation for this one. Y equals, on the bottom we had a lone x to give us a vertical asymptote at x equals 0. We had the x minus 1 brackets on top and bottom that would cancel. And then we had this 2x plus 3 we figured out on the top that would give us a horizontal asymptote of 2, and also evaluate at the point of discontinuity to give us the y value of 5. This is the rational equation in factored form, but keep in mind that on a quiz or an exam, they might FOIL these things out and give it to you in expanded form. It might look like 2x squared plus x minus 3 over x squared minus x, all of which is math that you can easily do. Page 451, number 4, 8A, B, and 9 is your assignment for this section. Make sure that you email me with any questions, and I'd love to walk you through some of these. Bye, guys.